to open the third session of the day. Today is the topic is cleaning and conditioning, and we have a very also specific topic in this session. Technology does not stop at the doorstep of a mill. To comply with the food safety regulation and consumer expectation, the modern technology is not anymore a choice, but a must. One of it is a color sorting. Michael mentioned brief in his presentation the features and advantages of color sorting in wheat cleaning. So I'm glad to introduce our next speaker. It's Gary FALK. Gary is sales manager for Africa, Middle East of Satake and Henry Simon. Gary, after earning his degree in business management, Gary has spent the last 21 years working in the Middle East and has been involved in many development projects in countries across the MENA region. So, Gary, you're welcome. The floor is yours.
Good morning from Manchester. I am Gary FALK, the Area Sales Manager for Henry Simon and Satake for Africa and the Middle East region. I'm honoured to be speaking to you all today, and my presentation is on the application of optical sorting machines in wheat milling. This has been an eventful year, to say the least. I hope you, your families, and all of your staff are safe and well. I never thought the comment, "I wouldn't touch them with a 6-foot pole," would become an international policy, but hey, here we are. Like all of you, we've been working throughout this global pandemic, ensuring that our deadlines are met. And on behalf of all of us at Henry Simon and Satake, we thank you for your continued business and support over the last year. Throughout the last 150 years, Satake and Henry Simon have been at the forefront of milling technology. The advancement in technology is enabling us to provide innovative and more intelligent milling solutions. At Henry Simon, we see great potential in the technological development, and we have a clear vision of making our customers' business more intelligent through innovative milling solutions. In 1878, Henry Simon installed its first roller mill at McDougall Brothers in Manchester. And in 1932, ESM, a Satake-owned company, designed and installed the first ever optical sorter. And since then, their use has become standard in many industries around the world. Optical sorters have been used by wheat breeders since the early 1990s. They are also widely used by farmers and grain suppliers, and they have become a vital and accepted part of the food processing industry. So how can an optical sorter help you, the millers? Well, to understand this, we need to address and talk about the challenges faced by the millers. Most importantly, you need to maximize profits by producing high quality flour at the lowest possible cost. This can be accomplished due to the more efficient separation and by achievement of an optical sorter. The resultant wheat on the first break can be cleaner, both from a wide range of impurities and from a microbial point of view. Sometimes a very specific impurity needs to be removed, for example, stink bug. This can be removed quite simply by optical sorting. The resultant flour would be potentially cleaner from a bran inclusion, flour color, or ash perspective. In this way, if some flour with a low ash content or bran inclusion is required, it would be possible to make less growth.
Mr. Gary, can you please unmute yourself? I think you muted. Yes, it's just 5 seconds that we're muted. All right. I don't know. Yeah, we are on the same slide.
Can you hear me now?
Yes, we can hear you clearly. Thank you.
Okay. So the resultant flour would be potentially cleaner from a bran inclusion, flour color, or ash perspective. In this way, if some of the flour with a low ash content or bran inclusion is required, it would be possible to make less low grade in order to achieve the required specification. thus making it more efficient and increasing profits. Microbially, this would be the most apparent when making flour for foods designed to be eaten by more vulnerable people, such as infants. Reducing power requirements. Optical sorters cost less to run than mechanical sorters. If the optical sorter replaces distoners and trio cylinders, then a lot of motors would be removed and a lot of air usage. The distoners are huge air users, all of which costs money. Reducing building costs. The footprint and weight of an optical sorter would be less than the equivalent mechanical sorters, hence reduce floor plate space and possibly reduce building costs. Removing defect that can't be removed by mechanical cleaning. This is certainly true if the optical sorter is fitted with infrared cameras. Other than most impurities can be removed by mechanical means, but not as efficiently.
كبيرة مثل الحجارة والزجاج وبالتالي أجهزة الفرز البصري.
Or ochratoxin contamination, which could be very useful in some crop years, both from an ability to use the wheat that is not able to be used by other millers and from a food safety point of view. So how do optical sorters actually work? The main components of an optical sorter are the feeder hopper, vibrating feeder, chute, light source, LED lit background, full color camera, optical outlet hopper, high frequency ejector, air compressor, air tank, and air filter. The feeding system consists of feeding hopper, vibrating feeder and chute. Raw materials enter the vibrating feeder from the feeding hopper. Then it will automatically be arranged into a series of continuous current lines by vibration and a guiding mechanism, and fall to a detection zone at a constant speed after being accelerated by the chute to ensure that the material is clearly present in the sorting cabinet. The feeding system also controls the capacity of the optical sorting machine in addition to the function of providing raw material. The feeders can be controlled individually to give a consistent flow of products. Each individual grain passes through the scan line using the RGB sensors and advanced signal processing. A signal is sent to the ejectors, and using a combination of the full color cameras and intelligent signal processing can determine whether the grain should be accepted or rejected. The optoelectronic system is the core part of the optical sorting machine, which is mainly comprised of an LED light source and related auxiliary devices. The light source provides stable uniform illumination of the material being tested to be measured into an electrical signal in the detection area. The sorting system consists of accessories such as a sorting cabinet, high frequency ejectors, and compressed air supply. The ejectors have been experimentally proved, and that the ejector pitch and the number of ejectors is one of the key factors affecting the accuracy of the optical sorter. The cleaning system consists of cylinders, gas cleaning wiper blades, and other components. Because some of the incoming grain comes with dust and other impurities that may accumulate to the viewing chamber during the sorting process. Once the dust and the impurities are attached to the window, the camera may cause problems such as false detection, which will affect the sorting accuracy and increased rejection. Optical sorters will work on almost any free-flowing grains, such as rice, wheat, maize, oats, barley, sorghum, and pulses. Optical sorters are a critical part of the cleaning system. They are not, however, a one-hit solution to all your cleaning requirements. To maximize benefit of a sorter, they should be preceded by a mechanical cleaning system that will remove the oversize and undersize impurities to ensure that the continuous and even flow through the machine. These images show grains that have been passed through an optical sorter and quite clearly highlight what they can remove that can't be done by conventional cleaning machines. Optical sorters will work on almost any free-flowing grains, such as rice, wheat, maize, oats, barley, sorghum, and pulses. Optical sorters are a critical part of a cleaning system. They are not, however, a one-hit solution for all the cleaning requirements. To maximize the benefit of a sorter, they should be preceded by a mechanical cleaning system that will remove the oversize and undersize impurities to ensure the continuous and even flow through the machine. The images show grains that have been passed through an optical sorter and quite clearly highlight what they can remove and what can't be done by conventional cleaning machines. With maize, they can also separate white maize from yellow maize. With oats, they can separate the oats from the groats. They can remove the barley from wheat, as well as any discolored or immature grains and insect damage. Sorters can also remove some of the toxins and funguses and bacteria that contaminate grains, such as fusarium toxins, such as ochratoxin, vomitoxin, stink bug, and rat poison. Sorters are available in various capacities from a few hundred kilos to 30 tons per hour. Some examples, we have the Picasso. The Satake Picasso is an automatic, cost-effective, full-color, portable optical sorting machine for small and medium commercial applications. The REZS features the latest full-color RGB technology, intelligent and innovative software, and flexible configurations. The REZS is perfectly suited for a small to medium commercial use. The Satake REZX optical sorter range offers cost-effective, high-capacity machines featuring the latest full-color RGB technology. Intelligent and innovative software and flexible configurations and resort options that are easily changed by the user to adapt to different product and capacity needs, which make it perfectly suited to medium and large commercial use. No matter which model you require, all Satake sorters come with the same high-level components and software which relate to high performance and user-friendly functionality, such as large chutes. All operator interface is done by a large touchscreen panel, easy access hoppers to see accepts and rejects, which allow the operator to easily confirm the performance of the sort. In a flour mill operation, we would always recommend a resort. For example, on the 3-chute REZS, we would use 2 chutes for primary accept and reject and 1 chute for resort, thus eliminating the loss of good product. Optical sorters nowadays typically use full color camera technology, allowing them to work on a wide range of applications by removing impurities by color and shade differences. Color cameras can differentiate between 16 million different color shades. The sorters that I have described so far are full color, and this is a step forward from previous sorters, which were monochromatic, otherwise known as contrast sorters, which could just differentiate between light and dark. Looking at the pictures, you can see a sample that is shown under monochromatic conditions and full color conditions. For instance, in a monochromatic sort, we would have to select one part of the visible spectrum, in this case, the red part, and hence we would only have been able to reject the brown grain, and other 2 defects, the yellow and the green, would have passed with the accept product as they look the same color as the orange grain. Now on a full color camera sorter, we can use all the colors in the visible spectrum, RGB, red, green, and blue. And we can distinguish the exact color of each piece of defect. So the brown, yellow, and green grain would be rejected, leaving a pure orange accept. However, if the application required is to remove foreign material with a similar color to the accepts or is transparent, such as glass, then the optional addition of infrared sensors is required. Advanced infrared NIR technology can detect the moisture differences between organic and inorganic material, such as glass, plastic, stones, and other items that have similar color to the accept product and can now easily be detected and rejected. The cameras recognize subtle color differences, contributing to food security and improving the final product quality. The optical sorting machine can be integrated in the cleaning flow diagram of wheat mills. Depending on the mill's requirements in terms of cleaning capacity, availability of space, and efficiency of existing mechanical cleaning equipment. The optical sorting machines can be integrated in the first cleaning section or in the second cleaning section. The optical sorter can be integrated along with the existing machinery or instead of certain cleaning machines, such as spiral seed separators and indented cylinders. When using the gravity selector in the first cleaning section, the optical sorter is fitted with lesser product feed chutes. The gravity selector is set to deliver about 25 to 40% of the full feed, which in turn reduces the feed on the optical sorter. The heavier wheat phase from the gravity selector is sent directly to the scourer. This is ideally suited to mills with limited space or budget. An optical sorter can also be integrated in the second cleaning section. It can be integrated between the scourer or debranner and the first break bin. In this location, the optical sorter could be a smaller unit because it could be rated on the capacity of the mill rather than the cleaning capacity, which is generally about 15% higher. It can be very effective as a flow rate of wheat stream is steadier and a lower in capacity. At this location, the screening and broken grains that are removed by the cleaning system can be recovered by a small optical sorter. The accepted good product can be fed back to the original input of the sorter or mixed with the sorted good product. This was a recent test we carried out in South Africa, where we placed a Pickerson optical sorter to scan the rejected grains from the indented cylinder. We found that on average, approximately 40 kilos of product was being rejected every hour by the cylinder. As you can quite clearly see, a large amount of good quality grain was recovered by the Pickerson. In fact, it was over 96%. Just over 38 kilos of good quality grain was literally being thrown away every hour at this mill before we install the optical sorter. Sadly, this is something we see at almost every mill we visit. Thousands of dollars worth of good product needlessly going to waste. As you can see from the slide, once the Pickerson was installed, this mill began to see an increased return on its investment every month of $5,411 and a total of just under $65,000 within 1 year. The Pickerson costs just $42,000 and requires less than $1,000 in spare parts every year. Even after freight costs and installation fees, the Pickerson will pay for itself in under 12 months. Take a moment and think about your own mills. How much good grain are you losing every year? A simple solution like this one is very easy to install, very easy and simple to maintain, and could save you upwards of $50,000 every year. Up until now, we've primarily talked about wheat applications, but optical sorters can also be used for maize milling. They can be used in the removal of discolored or moldy maize, white maize, soya, stones, and cob. These pictures show a typical example of a sort for a maize in pre-cleaning section. As you can see, less than 0.5% of the maize is rejected, but the ability to efficiently separate impurities from maize without appreciable maize loss can bring a huge saving to you, the miller. Specific product testing can take place prior to installation of the optical sorter, and this ensures accurate and consistent removal of specific impurities or a range of impurities. So what are the product advantages? Large capacity and cost effective. Up to 30 tons on a single machine or multiple smaller machines if space is an issue. Sorters are now very cost effective. Previous sorters were low capacity and expensive. And now with the advancement in technology and electrical components being more cheaper and more readily available. Previous generation monogrammatic sorters would be about $11,000 per ton, whereas today you get the advantage of a full color sorters at about $4,500 per ton. LED lighting offer much longer lifetime of up to 20,000 hours. Running 24/7, that equates to about 3 years. The older generation lights only lasted for about 3,000 hours. Typically, operators can be trained in 1 to 2 days and will have a full understanding of how to operate the sorter and maximize the efficiency and profitability of the sort. All our sorters have easy access points, require no special tools or shutdown, allowing for easy maintenance and cleaning. The new sorters have full color cameras for subtle color differences and can recognize 16 million colors, and they work very similar to the human eye. With remote access sorting,
تفرق ما بين ألوان الحبوب بطريقة
assistance, thus requiring less. Now there are no changeover parts between products. Everything is in the new software. With current machines, it's all electronic. On old machines, you would need to change lamps, backgrounds, filters, and shoots. Quick and easy product and defect setup. You now simply present the product to the camera and the software will take care of the rest. The software will recognize the core color of the product and this becomes its reference. The same is done with the defects and the software automatically sets the sensitivity to remove the defected grains. Sorters are now much more reliable and can be installed directly on the mill floor. They are very simple to install with single phase power and compressed air, which are already available in a mill plant. "50 presets can now be programmed for product settings and can quickly and easily be saved to use again on future sorts. The software automatically makes lamp adjustments to match the preset. Saved presets can be duplicated and then additional accepts and defects added quickly to set up for similar sorts. Our machines have auto calibration, which calibrates themselves every time it wipes, so there is no need to reboot for recalibration, thus meaning no downtime. Basically, the machine will auto clean the window every 30 minutes to ensure the results are consistent. When it does this, the software will automatically smooth the camera signals for any differences found. Some of the machines have to stop to process this, but not with the Satake range. A quick return on investment, as shown in the previous slides, your initial outlay can be returned in less than 12 months. So to conclude, with today's high food standards, wheat millers need the new advanced technologies such as optical sorters in order to meet the demands of market requirements. It's now time to use new technology to your advantage. Why rely on traditional mechanical cleaning only? Optical sorters are more efficient and reliable and have captured the interest of wheat processors who want a more consistent end product. The optical sorter is not only used for better quality it provides, but also they save energy and it uses electronics rather than heavy, expensive motors. Optical sorters are easy to maintain. They are relatively inexpensive to maintain as well compared to the traditional cleaning machines. The optical sorter was first adopted in durum milling process, and they are highly effective in a removal of ergot and black seed contaminants. Thus, millers are now producing higher quality, safer, and cleaner semolina. Today, the application of optical sorters has become widely used in wheat flour milling to produce high quality and safer flour by ensuring the removal of allergens such as soya in wheat. Optical sorting is now considered a better, if not vital, option for the inclusion in any modern wheat cleaning plant. Thank you very much for your time today, and I hope that this presentation has given you a better understanding of how optical sorters can become a vital part of your mill. If at any time you'd like to know more, please do not hesitate to contact either myself or anyone at our team. Thank you.
Thank you, Gary, for this inspiring presentation. Now we can place questions, please, audience. Now, from my side, just listening to your presentation, I have seen you explain the concepts of color sorting installed in the first cleaning and also second cleaning. So what is your recommendation to millers? What would you recommend? In which case using it in the first cleaning and when in second cleaning?
It's a very good question, Martin. It's one we get asked quite a lot of the time. I mean, look, typically on a brand new mill, you'd have the sorter in the first cleaning section, simply because you want to remove any impurities as quickly as you can in the cleaning process. In a new mill, all the machinery, storage bins, etc., are new and they work efficiently. So it makes sense to have the optical sorter in the first cleaning section and to remove the contaminants as quickly as possible. However, when it comes to installing an optical sorter in an existing mill, which is most of the time, there are many factors which we need to consider. Most importantly is where we can fit the sorter in the mill. Where do we have the space? We need to ensure minimum disruption to the flow of the mill and at most the most cost-effective solution. We'd also need to probably consider the customer's budget, and this will also determine the size of the sorter that we can install and thus determine whether we put it in the first cleaning or second cleaning section. You'd probably also need to consider the age of the mill and more so the age of the cleaning machinery and the storage bins. Older machinery may not work so well, and the older bins tend to have a buildup of dirt and contaminants, and thus having a sorter in the first cleaning section wouldn't be very conductive, as contaminants from further down the line would enter the mill flow. So in this case, we'd probably recommend a sorter prior to the first break, so it can act as a sort of policeman and stop all the contaminants entering the first break.
Okay, thank you, Gary. And we have a question from Hassan, optical sorter or color sorter. Any need to have both in the same screening room?
An optical sorter is a color sorter. We call them optical sorters simply because now they don't just detect color differences. They, as you see with the infrared, they can detect the moisture content. They also have shape recognition usage now as well. So, but I would definitely recommend that you should always have at least one in the screen room.
Excellent, thank you. I have a question. You mentioned about return on investment. To calculate the return on investment, you mentioned the benefits, but on the other side, there are also costs. Do you have a benchmark on cost? How much is the operation of a color sorter costing to a miller?
Yeah, this again is one we get asked quite a lot, and it is very difficult to sort of calculate, as it's all dependent on the type of color sorter and the product being milled. I would say the cost of running vibrating chutes and electronics is very minimal compared to electrical motors, as they do not require much power. The compressed air would probably be the highest cost. Let's say if you're using 30 ton per hour sorter, such as the REZX 7500, you'd need to install a 22 kilowatt compressor, assuming that it does need an air compressed system, running all the time. In the UK, this would be about $1.40 per hour. But of course, it all depends on the cost, the electrical costs in the specific country. I mean, assume the throughput is about 15 tons per hour, then it would cost about $1.40 per 15 ton, or about 10 cents per ton per hour. Again, this is dependent on the throughput, and these are just theoretical costs and savings. And these can only be finalized knowing and mention variables specific to each mill. I mean, the real return is on how much more efficient the optical sorter is compared to just a mechanical machine. Separation can take place without much loss of the good product, and this is the real saving. I mean, for example, if the grist cost is $233 per ton, and with the optical sorting, you can prevent a loss of, say, 0.3% of product, then you can effectively save about 72 cents per ton of product. On a 400 ton per day mill, this could amount to about $288 a day. And if, say, for example, a sorter sells at, say, $110,000, this would pay for itself in about 370 days. You know, as we always say, it depends on each mill. And we would always recommend that we come and do a site visit and inspection, and see what sorter is most suitable to the specific mill.
Okay, noted, Gary. Every sorter has also wear and tear parts. So the question from Dori, does it have more wear and tear in the dry wheat versus dampened wheat?
I wouldn't say so, no. Again, this would be one really for one of our technicians, but I wouldn't say so, no.
And does the dust have any effect on the sorting efficiency? So first cleaning, second cleaning, or general?
Yeah, I mean, the dust is one of the biggest problems for color sorters. And as I mentioned in my presentation, the auto calibration feature that we have now in all of our sorter lines has really drastically improved the efficiency of the sorter. I mean, they're wiped clean automatically every 30 minutes, thus making sure that the camera and everything can detect all of the defects.
Fine. So I have another question. Can a color sorter be used for grading wheat as per quality parameters, say high protein, low ash, or something else?
You'll have to forgive my technical knowledge on this one. I'm not sure on this.
So you can't say anything on this? Grading wheat with a color sorter?
No, unfortunately, it's not something that I can answer myself, but I'll have one of my technicians answer the question for you.
Okay. Fine. There are no further questions from the chat. So I have my final question. What's the future? Is there, you know, IT is on a fast evolution. What will be the next generation of optical sorter?
Again, this is hard to expand on, as it can go in so many ways. Many would say that the market has reached its peak as far as conventional color sorting goes. There is nothing better to date than a full color RGB camera. It works in the same principle as the human eye, using full RGB color. The human eye can see about 10 million colors, whereas the optical sorters now can see up to 16 million different colors. So the market is certainly ahead on that aspect. The next generation of optical sorters, in my opinion, will probably be a combination of RGB cameras, NIR, infrared options, shape technology, and AI software. The idea being to have one frame that can be fitted with that customer, what the customer needs. A simple wheat farmer just needs RGB technology to remove the ergot, but a sophisticated mill may require RGB infrared on multiple applications, and the software to allow the mill to get the accurate real-time data on what the sorter is removing from the product flow. All of this, I mean, was discussed in my presentation, but the need for flexibility, the need for ease of cleaning, the improved sorting at lower costs, all need to be considered as standards across the industry to continue the increase. But it's a difficult one.
Okay. Now, but just you mentioned shape detection. What we know, shape detection is mainly used in rice milling. Do you see also this technology in wheat milling?
Yeah, I mean, you can see by insect damage, damages a lot of grain. So it can most certainly be a good use for this sort of type in wheat milling. You know, you're trying to remove as much contaminant as possible, and the optical sorter is the best machine for that.
Good. Dory has a question. Some of the use of sorting machine is to decrease the mycotoxin level. So is the rejected wheat will not be used in milling? Is that correct?
Yes, as discussed with the mycotoxins, you don't want them anywhere near your end product. You want them removed as quickly as possible. So the sorter will take these and reject them.
Excellent. Fine. I would say no further questions coming up, so I would come to the end. Miriam, is there from your side anything to add?
No, that's fine from our side. We are just now going to, actually, I'm giving you the floor for the closing remarks of the day before we give the instructions for tomorrow, because everyone knows that this is 3 days forum, and we have today, tomorrow, and after tomorrow. And then after your closing notes, Mr. Martin, we will be just sharing a quick overview of what to expect for tomorrow and how to connect.
Fine. So first, thank you, Gary, for your inspiring and really technical input. Thank you very much. So it was a great day. Our first day, it's a pioneer session, and we made it. We talked about quality. We started with gluten. We talked about cleaning and conditioning, and very much in particular color sorting. So it's the start for every miller to prepare the wheat, let it mellow, and tomorrow we will enter to the second session. So thank you to all you presenters, speakers. Thank you, Miriam, and your team. So we are ready for tomorrow. But also a great appreciation to all the audience. You really shared your, you had questions, and that made our interactive virtual forum, which is really was very lively. Thanks to all of you.
I wish if everyone can open actually now the video, because we asked you, to turn it off, but it would be nice for all of us just to quickly see each other before we close this this day. I can see some are wearing the masks, so please be safe, remain safe. It's so nice to see you all, and it's good for you to see each other as colleagues and clients, partners, so you can swipe your screen, say hi if you want. Let's do like a very spontaneous reaction, because you can see like actually, you know what? This is a good opportunity for us to do a screenshot, and we will be sharing this on our social media for IAOM. So just take a few seconds of a happy face or like a crazy move, and then we will be sharing it on our social media. So we will be taking 3 screenshots. Please, everyone, put your camera. I can see many of you did not put yet.
So Gary, your camera is off.
Yes, Gary, please, Mr. Gary, please put on your camera. I can see as well Angie, Boniface, Michael, Joanna, Claudia, Ranish, Harith, Ramis. I mean, a lot of you did not put yet. So just a few seconds, and then we will be having a group picture. So thank you all for really joining today. My colleagues are taking the pictures, so I'm not sure if they will be catching the smile, but they will be catching you moving or not. Okay, are we done, Sherihan? One more? Okay, one more to go, and then you will be seeing yourself tagged on our IAOM social media pages. So we have LinkedIn, we have Twitter, we have Instagram and Facebook. So please follow us if you want to see your face. And We're good with the picture? Okay. No worries, Andy. If you cannot open the webcam, try it tomorrow, and we will be doing another group photo tomorrow. Okay, so we are done with the group photo. Thank you so much.